Hi, I'm Sir Raynon Flores, teacher and advisor of Grade 11 STEM at Orani National High School, Senior High School Department. Today's lesson in physical science, we're going to differentiate dispersion, scattering, interference, and diffraction of light. First, we have dispersion. Dispersion is the process of splitting of white light into 7 colors. As you can see, when the light undergoes refraction, as the speed of light changes, the white light splits into 7 colors. Examples of dispersion are number 1, formation of rainbow during a cloudy day. When sunlight passes through the raindrops acts like a small prism. Some of the sunlight is reflected and some other part is refracted. The refracted light, while passing through the water, splits into its components or the 7 colors and appears as rainbow. Number 2, through a window glass, light reflects as well as refracts. We can observe the objects through the glass due to refraction. We can also observe the reflection as we can observe our own image by looking at the same window glass. Due to the dispersion of sunlight and internal reflection by the window glass, we see the rainbow colors. Second, we have scattering. Scattering is a general physical phenomenon that means change the path of object as a result from collision. Scattering happens on objects smaller. A great example is when the sun's rays pass through clouds. The light is deflected off of its straight path and scatters in many directions. Now, to better understand, I'll show you a little experiment about scattering of light. I have in here a laser beam, and if I will switch on, you can see the dot on this board. Okay? But the question is, did you see the path of light traveling from here to this board? Of course not. Okay? Now let us try another experiment. But this time, okay, I have a saucer and baby powder. I will put a little bit of baby powder in this saucer. Okay, and then I will give a little blow. But this time, let me turn off the light. Okay, please observe carefully. Okay, did you see the path of light now? Now, we observe the path of light in the dust from the powder. The reason why we did not see the light here, because the air particles is very small. Unlike in the dust particles, we obviously see the path of light. Okay? Because there is increase in particle size. This process of light getting divided in different directions due to interaction of particles of the medium is known as the scattering of light. And this is what happened, why we can able to see the path of light in our naked eye. Now, please observe these two containers. The first container is pure water. And the other container is a colloidal solution, meaning that is a mixture of baby powder and water. Okay, look at this. Did you observe any path of light in this container? No. How about in this container? Evidently, yes, the path of the light is visible due to colloidal particles in a mixture, and the scattering of light in colloidal mixture is called Tyndall effect. The Tyndall effect is the effect of light scattering in colloidal dispersion, while showing no light in a true solution. The effect is named for the 19th century British physicist John Tyndall, who first studied it extensively. Third, we have interference. Is defined when two or more light waves having the same frequency, same wavelength, and same amplitude meet together in a medium at a point. They cancel or enhance the effect of each other at that point. There are two types of interference of light: constructive interference and destructive interference. In constructive interference, two waves of light reinforce each other. In destructive interference, two waves cancel the effects of each other. Example of interference: oil and water creates an interference pattern in the colors of the spectrum. And last, we have diffraction. Diffraction is bending of light near material at the edge while going through aperture while diffracting on grid, both in reflection and transition. For example, when the beam of light falls on the edge of an object, it will not continue as a straight line. The point where the light hits the edge acts as a second wave source. As a result, some of the light waves bend slightly around the corner. Because of diffraction, sharp shadows are not produced, and there will be a blur at the edge of the shadow of the object. This phenomenon is the result of interference. Now, based on our lesson, try to answer these questions.